In this section, we will talk about just another way to solve a system of linear equations. Now, just as a review, we have talked about the substitution method and the elimination method. And that was in section 11.1 of the current semester. We also talked about matrix row reduction. And that was in section 11.2. Now in 11.3 we have yet another way to solve systems of linear equations, and it's called Kramer's rule. But before we can actually solve these problems, we need to talk about what a determinant is. And a determinant looks much like a matrix. The difference is that determinants are square. That means their dimensions are either 2 by 2 or 3 by 3 or 4 by 4. And the notation is a little bit differently also. Remember, with a matrix, we used this bracket. With a determinant, we just used straight bars. Now this is a 2 by 2 determinant. It has 2 rows and 2 columns. And anytime you have a 2 by 2 determinant, you solve it by starting along the diagonal that starts up at the top left-hand corner, and you multiply those two numbers together. So 5 times 3, and then you subtract, and it's always a subtraction, the product of the other two numbers. So 4 times -1. So this would give me 5 times 3, which is 15, minus 4 times -1, which is -4. 15 minus a -4 is 15 plus 4, which is 19. So the value of a determinant is a single number, and in this case, the answer is 19. Now let's look at the second example, which has a determinant involved in an equation. And you'll see that this is a 2 by 2 determinant with t's in the first row and 4 and 6 in the second row. And we know that the value of that determinant has got to equal 8. So let's see if we can figure out what t is equal to. Starting in the upper left-hand corner, you multiply along that diagonal. So we have 6 times t, or 6t, minus, remember the minus, and now you multiply the numbers along the other diagonal, 4 times t. And according to our problem, that has to equal 8. Well, we know 6 minus 4 is 2, so 2t equals 8. That means t equals 4. So the solution there for my determinant value of t is 4. So now let's use Kramer's rule to solve some systems of linear equations. The first thing that we do is we set up some determinants. The first determinant is capital D determinant, and it is a 2 by 2. And its numbers contained within the determinant are the coefficients of the x's and the y's. So 2, 1, that's the coefficients of the x's, and 3, -4, that's the coefficients of the y's. We also set up what's called a d sub x determinant and a d sub y determinant. Now d sub x is found by taking these numbers on the right side of the equal sign and putting those in the first column where the x's normally go. And then the second column remains the same as the d. So we've just replaced the 2, 1 with the -619 for the d sub x. d sub y, we're going to put the negative 6 and 19 in the y column and leave the x column the same. So the x column remains the same and the y column is replaced with the negative 6, 19. And now we solve each of those determinants. 2 times negative 4 is negative 8 minus 1 times 3 is 3. That gives me a negative 11. Negative 6 times negative 4 is 24 minus 19 times 3 is 57. And if we subtract those, we get a negative 33. 2 times 19 is 38 minus 1 times negative 6 is negative 6. And 38 minus negative 6 is 44. So now we are ready to find our solution. X is always equal to dx divided by d. Therefore, x will equal negative 33 divided by negative 11, which equals 3. Y is always equal to dy divided by d, so that would be 44 divided by negative 11, which is negative 4. So x is 3 and y is negative 4. And you can always check your answer by plugging 3 in for x and negative 4 in for y into your original equations. And if you take time to do that, you will see that this is the correct answer. Now I'm going to go through the process again for this problem so that you can see just one more example. We're going to set up our d sub x, and our d sub y. They will all be 2 by 2 determinants. So d will be the coefficients of the x's and the y's. dx, we're going to put the 9, 1 in the x column, and the y column will stay the same. dy, we're going to put the 9, 1 in the y column, and the x column will stay the same. Now we evaluate each of those determinants. Here we have negative 1, if I multiply 1 times negative 1, minus 1 times 1 is 1, or negative 2. Here we have negative 9, minus 1, negative 10. Here we have 1, minus 9, negative 8. So make sure you can do those determinants easily before you go on. Then x will equal dx over d, which is negative 10 over negative 2, or 5. Y will equal dy divided by d, which is negative 8 divided by negative 2, which is 4. Now this one is really easy to check because we know that 5 plus 4 is 9 and 5 minus 4 is 1. So we have the correct answer.